Ooh. I'll go ahead and get started, and whoever joins in, joins in. But this is what I'm saying. I'm going to get some codes for y'all before the week's out, hopefully. We'll see. Just depends on how quick we can get them and everything like that. But this is your Cengage learning online simulation program, basically. It comes in a small little tiny pamphlet. That's all it is. Inside's got an access code. You can access this on apps and any web browser. You should be able to get access to it. It pretty much walks you through in that booklet what website to go to and everything. But it's really, really cool, this program, how it operates and works. So you've got a couple of different options for you to interact with the system. The most basic style is we've got the basics of electricity, where it talks about circuits, whether you've got what's a basic circuit, how to use a meter, stuff like that. We'll go over. It has it where it walks you through how to read wiring diagrams, and then you've got it where it'll also talk to you about, soft skills, like safety skills, basic stuff like that. And when you really get into it, what we're going to do tonight a little bit is we'll do some troubleshooting. You can choose heating or cooling, do you go commercial, you go residential. The only thing refrigeration-wise they've got is a commercial freezer, but even that is still pretty cool. So I'll show you guys a little bit of a split residential air conditioning system, and then we'll work as a group and basically go through this together. So go into it, go into the training mode. Now the training mode's got where it actually will tell you step by step what you need to do. And the challenge mode is the other one. Basically, it's once you've done all the training modes, you'll have seen every fault for a system that it's got, which is just about every fault you're going to see for a typical HVAC system. And then after you go through pretty much every problem, it's just going to give you a random one without telling you what to do. And you just got to know, because the main thing this tells you and will teach you is the fundamental way to troubleshoot and check a system. What are the first steps? What do I do? What's step 1, 2, 3, 4? What do I go through? What do I do? Because you're going to see, we're going to do just a couple of them right to start off, and you're going to see me do the exact same thing on every one of these units. All right. If I go to my procedure guide, every single one of them starts the same way. There's no cool air. We've got no AC. We're going to go. We're going to start. We're going to go with thermostat. So there's 2 ways to control this guy. I can either use my arrow keys and walk around, which is kind of annoying. It takes some time. Or I can just click in the bottom right. There's a quick thing where I can go to different components. So this, I click thermostat. So I see my fan is an auto. The system's set to auto. Well, I need to set it to cooling. So I click my control right there to set to cool. And I go to my procedure guy. I say, okay, yep, I've set it to cool. That's good. So now I'm going to say, it says, okay, is the indoor fan running? So I go to the indoor unit. You literally just click off covers on the side, and the indoor fan, I would actually hear that running, and I would actually see blue arrows pointing to show, okay, yeah, it's rotating. So currently, is it running? No. All right. Next thing I'm going to check is I'm going to go to that outdoor unit. The outdoor fan and compressor running. All right, well, the fan's definitely running. That looks like it. Let's check out that compressor. So if I click on it once, I can click on it and feel it. Yep, feels warm to the touch. So yes, it is cycling. We got it where it's coming on. Turn it off. If we want to force it to cycle, we can always disconnect our power and then start right back up. And again, our pressure still feels normal. So yes, it's cycling on. All right, so it tells me right there, using the multimeter on the AC setting is 24 volts AC, measured across the indoor fan relay coil on the green and blue wire. It even tells me what wires I need to go to and everything. So I go to the indoor unit, go on my indoor fan relay. Now, I've done this quite a few times, so I'm pretty comfortable at this point. What's what? When y'all start out, you've got it where there's all sorts of resources. I have wiring diagrams like this that you can zoom in on. You can get really close and see, okay, well, what is connected to what? It's nice and clear. The other thing it'll give you is it'll actually give you a pictorial diagram. What's connected to what? So if I just read my instructions, the IFR coil, I'd look around in the picture, I see IFR, and I look right here, there it is. There's my IFR. This guy, straight ahead with these 6 wires going into it. All right, now it's saying to check the blue and green wire. So if I go into my little tools thing, I can click on the multimeter, click on voltage of AC. And now here's what you're gonna do. This is your basic checkup on a relay. That's all we're doing, just checking to make sure, okay. All right, power path low. All right, power's going to the system. We've got 24 volts. It's getting to that thermostat because it's turning on. We're getting 24 volts at our contactor outside. We're getting high voltage to our unit outside. It's just our indoor fan's not working. So we divided it into 2 sections. What's working, what's not working. Outdoor unit, working. Indoor unit, not working. So we start looking at our indoor unit's path of power that it takes. For the air conditioning system, what we're going to have is that path of power. We're going to have a low voltage control. You got your coil back here and everything, all right? And that low voltage control, or for cooling, should have it where we got 24 volts across that low voltage coil. That means we've got it, it's getting energy, and it should be working, all right? So we're getting 24 volts. The next thing it says is let's check our voltage coming into the relay. So this black and red wire at the top here, that is our high voltage coming in. That is our line, is what we call it. You got line voltage here, and we've got load voltage on the other side that's going to our fan. So voltage just sits there until this gets 24 volts. Once this gets 24 volts, it's going to complete the path from these top terminals to these bottom terminals. And that's what we should be seeing. So we're getting 24, we're getting 240 in. Last thing we're going to check is we're going to check and see if we're getting 240 to come out. Put our meter on there, 0 volts AC. See that? Go ahead and shut this meter off. If I've got 24 volt signal to a relay coil, I've got high voltage coming in, but I do not have high voltage coming out, it is a bad relay. So when you do these simulations, it'll actually tell you, you can click on the part, you replace it, it'll say you want to repair this for a cost of $130, and then you got to choose yes or no. For this one, then it says you're completed. All right, we've only got a few things left to do before we ever finish our calls, or these are ever really done. Close up your units. And always go to the broom, clean up after yourself. All right, whenever you're on a call residentially, you want to make it where no one ever knows that you were there except for the person that was at the house at the time. You know, you want to have it where whoever was out during the day, you know, whether it was the husband or the wife or whomever, you know, the other person gets back to the house and they say, "Oh, did the HVAC guy even come by today? I didn't notice anything. Did he come in? Oh yeah, he came by. He checked everything out. He's good. We're fine. You know, he fixed the unit. The AC's kicking back on. You know, just about an hour ago. Okay, cool. I hadn't felt anything, but that's good to hear that he was out there. You know, and it's why does he not know? Because you're not leaving muddy foot tracks everywhere. You're not leaving parts out everywhere. You're not, you know, leaving tools and all that kind of stuff. Clean it up as the last step you do. Clean up, make sure there's no trace of you left in that structure, and then head out to your next call, you know. So we'll go over another one, and then I'll have y'all walk through as a group. I'll have you guys, I want you to give me, you know, tell me, what do I need to do? What's my steps? What's my process? It's gonna be the same again and again and again. So we're gonna start another one. Same process as last time. We always go to our control system on any call. Residential, refrigeration, commercial, industrial, we go to our controls. And that's where we start, because that's what should tell the system what's going on and off. So for our controls for residential, it's always starting at the thermostat. Always turn that puppy to cold, say, all right, let's get the AC going, let's get that fired up. And then the next thing you're gonna do is you're gonna go to that indoor unit. You're gonna see, yep, is my indoor fan running? I've got those blue wires, blue arrows. So I've got airflow. So yes, my indoor fan is running. So let's go check my outdoor unit. I'm out there for a reason. Somebody said, hey, there's no AC. So I look at my outdoor unit, is my outdoor fan running? Yep, it's definitely running. It's spinning like crazy. What about the compressor? It's not sounding as loud as it was before. The compressor feels normal. We can force the system to cycle on or off. Disconnect it. Reconnect. So yeah, compressor cycling on, it's coming on. So, the person's saying they're getting no cooling. My compressor's running, my outdoor fan's running, indoor blower motor. The last thing it's saying is the outdoor condenser coil clean of debris? Aha! And that's all it is. Now, it's not going to be that easy and simple sometimes to figure out, is it the outdoor unit having some sort of debris or anything like that? But cleaning it off, oh, I just brushed some leaves off. We have different tools and supplies that make it so we can clean outdoor units, clean indoor coils. Coil cleaners are very, very popular. They're one of the most common treatments for residential systems for maintenance. Basically, your compressor is the heart of your system. It's what pumps the refrigerant around and allows it to move from the evaporator to the condenser, from the condenser to the evaporator. That's all because your compressor's running. Now, the thing about it is, if the compressor is the heart of the system and it's pumping everything around, the evaporator coil and the condenser coil are the lungs of the system, all right? So if you have it where you're breathing, all right, which I hope all you are, you have it where oxygen comes in, goes into the bloodstream, pumps around the heart and everything like that, that they play off of each other, all right? You know, you stop breathing, you're not gonna get oxygen, you're not gonna get blood pumping. Your blood stops pumping, you're not gonna be able to keep breathing, you know, vice versa. But for a air conditioning system, the more that your coil is run and operated without any sort of protection, without any sort of coverage, with the very, basically, you know, it's just sitting out here in the elements, all right, all day, every day, and it's pulling air in from the sides here and then out of the top where all this red heat is coming off of. So coil cleanings, I usually do them pretty regularly. Air conditioning, as far as condenser coil especially, you can have it where you'll spray these things down. The cleaner for it foams up, like if you ever had it where you put hydrogen peroxide on the cut and it foams up, that's what this stuff kind of does, looks like. But you have it where it really expands like crazy. The whole thing looks like this crazy foaming at the mouth, like rabid air conditioning system, basically. And it pulls all of our nasty stuff to the front of that coil. And what it's going to do when we have all that stuff that's there and it's at the surface, we can rinse it off. I've had units where they look like they've been run for years and years and years, and it's maybe a 3-4-year-old system, but you get a coil cleaning across it, and then the customer, instead of seeing this gray, outdated, very just nasty coil, all of a sudden they're seeing this bright, shiny aluminum thing like it looked like when they first got it installed. They're like, oh, that's what it looked like when I first got the system. And then you have to tell them it's not supposed to look every day. And they're going to start paying more and more attention to that kind of stuff, because more of that debris building up on there is what's going to make it where we have a difficulty with heat transfer. It basically acts as an insulator. So you can have that with the indoor unit. You can have that just by having a dirty air filter. For the outdoor unit, you're typically going to see that where the coil just gets, it's going to get debris over time. Look at the elements. Look at what it's surrounded by. Look if there's, is it near some bushes? Is it near some trees that might have really high amounts of pollen? Is it next to some dog houses? I had it where a unit was 1 year old, and just because the fact that the units were next to a pair of dog houses with big fluffy golden retrievers in them, those units had it where, I'm not kidding you, when I had it where I could literally just, didn't have to do any cleaning. I could just pinch and pull off like a 1/4 inch thick layer of just dog hair built up on that coil over a year. That's all it took, 1 year of operation, and their system was already failing. It was really, really bad to see. I had to go know, like, hey, you just got to get dogs away from the systems. They just didn't want to hear that, so that was fun. All right, so this one, I'm going to go ahead. I'm going to let you all tell me what I need to do. Again, we got another call. They're saying we've got no air conditioning, and they want to know what's going on with that system. Let me get a different one real quick. There we go. So first step, always, whenever we go to a call, where are we going to go?
Go to the thermostat.
Thermostat, always. What are we going to do with the thermostat?
Set it to cool.
Set it to cool. And this is going to seem boring, but trust me, you guys are going to, this is what you do day in, day out, is going to be just making sure you go through these steps every time. So we go in, make sure we set it to cool. What's our next step we're going to get to?
The fan blower.
Yeah, so we're going to check that indoor fan, that blower motor. That guy's running. That's looking good. All right, what's our next step we're going to head out to? Indoor unit's good.
The compressor. The compressor outside?
Let's go to that outdoor unit. Uh-oh.
The fan not blowing.
The fan's not blowing. Let me check my compressor. And the compressor is cool, so it's definitely off. In fact, if you touch a compressor and it's feeling cool, it has not been running. So compressor's not running, outdoor fan's not running. So, got a couple of things as far as the outdoor unit's concerned. All right, down here, in our controls and everything, we've got the contactor, we've got our capacitor, we've got our thermostat wires, and our main voltage coming into that system. So what it's suggesting for us is to check and see that contactor and look for a 24 volt signal. So you see that yellow wire right there? That's what I was talking about before. That's your Y connection coming from your thermostat. It sends 24 volts out to the coil, and then that blue wire is your common to complete that circuit. So we check, we take our multimeter. Check across the contactor coil. Should read 24 volts, which is what we're reading right now. So that's right as far as the control side of it. The only other connections we've got is not on that contactor is we've got 2 connections on the bottom, which are going to be for power coming in, high voltage. And then we got our high voltage coming out the other side of the contactor. So just like a relay, remember earlier before we had that relay where we checked the 24 volt coil, 240 coming in, 240 coming out, we're doing the same thing with the contactor. So we just saw 24 volts is good coming to the coil. While we're seeing 240 coming in, what should we check?
Check and see if it's coming out at the top.
Check and see if it's coming out at the top. So we'll go ahead, we'll look and see. I've got 0 volts. So what do you guys think? I've got 24 volts, control is getting there. 240 is getting to one side, but it's not coming out the other side.
Contactor.
Yeah, it's a bad contact. It's just not doing its job. It's getting the signal, it's getting the electricity it should, but it's just not doing its work anymore. So it's going to be
Not passing through. It's not making it, allowing it to pass through.
exactly. And this is a really common problem you're going to come across is replacing contactors. They're one of your more, I'd say, more common things to go wrong with the system. What do we got to do before we leave?
Close everything back up.
Yep, close everything back up, fire it back on. And go get that broom. Cover back on, back there. And there we go. All right. So let's see what we So we got another one, no cooling. Where are we going to go first?
Thermostat.
Thermostat every time.
Set to cool.
Yep.
Fan motor.
Check that fan motor. Fan motor is not on.
So is that what we checked the relay? That
Not yet. Check one more thing before we go into the relay. So we checked to see we got our thermostat. We set it to cool. And we got our indoor fans not running. But what else can we check to see if it's running?
The outdoor fan.
Outdoor unit. So we check our outdoor unit as well, just to make sure. The outdoor unit's off as well. So both our indoor and our outdoor not working right now. So if I've got where my whole system, nothing's coming on except for, let's say, my thermostat, let's say that's running on batteries. So as far as I know, nothing's coming on in my system. Where would I start looking for power?
transformer.
Check with that transformer. It's going to be one of your easiest spots because your transformer is always going to have your high voltage coming into it, and it's going to have your low voltage as well. So you're going to be able to see right there at a transformer. Okay, I have power, I have high voltage. Do I have low voltage? Are they both working? So we'll check our transformer out. So we're going to check, first thing we check is we check our high voltage coming in. We've got a red and a white wire. We got 240 coming in. Let's check and see what we got coming out the other side. We got nothing.
So the transformer bad.
Yeah, it's a bad transformer. Now, only other thing I would check besides this, honestly, would be checking to make sure that all the wires are tight. You know, if I've got a loose wire, that's the last thing I want, you know, to say, oh, it's a bad transformer. It could just be a loose wire. But it's all tight connections. We got 240 coming in. We don't have 24 coming out. Bad transformer. As soon as that's either is producing no voltage or low voltage, it's a bad transformer. If it's supposed to be producing 24 and it's only putting out, you know, 20 or 18, you know, oh yeah, it's putting out something. It's not enough to energize our coils or anything like that. So, all right, we'll go ahead. We'll replace that transformer.
Are those actual prices?
I don't know. I wouldn't say. I mean, 210 for replacing the transformer sounds about right. Pretty typical, just because the depending on the location of it and cost of it, depending on how the transformer it is. But yeah, 210, pretty typical. Some of these are a little low. Like I think they quote replacing the compressor at like $350. And compressors cost like $1,000 starting out. So yeah, it's some things a little more realistic than others. But the main thing is with the when you do the challenge mode, it's got it where, because it's not going to tell you step by step what to check, what wires to go to, and everything. If you just are guessing and placing a bunch of parts in, it actually keeps a log and tells you how much you've cost the customer for parts and labor and everything like that. So that was $160 for the transformer, or no, $160 for labor, sorry, and then $50 for the transformer itself, which that sounds about right. Transformers are typically pretty cheap, and they're a really common part to go bad in the system. So replacing one is not too bad. 160 labor, good lord. Yeah. Sounds about right. If they're not including a dispatch fee or something like that in the overall cost. So last thing I always want to go to, got my broom. So I'm going to show you guys a different feature on this real quick, besides the air conditioning systems. So we've got basic stuff we can look at too. So if you want to, if you ever need a review, especially basic circuits and stuff like that, this walks you through step by step how does power flow into a load, right? And you can change it, you can experiment with this. It's got it where you can, it's got a meter, you can just look at voltage. So if I check voltage coming in and coming out, I'm gonna read my source voltage on the load. But if I check voltage, you know, L1 coming into a light bulb, it's gonna read 0 because there's no difference, there's no load. As soon as there's a load and there's a difference of voltage, that's what your meter is gonna read, is that difference. But there's a whole section on meter reading. This one just shows you, you know, what's gonna happen to my amperage if I, let's say, change out this light bulb for a 240 volt light bulb. And what happens if I increase the power and I put in the really low light bulb, you know, and it burns out, you know. So actually, this is a pretty cool one as well as far as different stuff on here. I'd like for y'all to be able to experiment with once everybody gets to it. But I wanted to make sure to show you that real quick. And then, what was the other stuff? Goes into motors. You've got where it goes over a series of parallel circuits, how to read wiring diagrams. I want to do some more of these, you know, basically during your nightly stuff and have you guys go through them with me, as well as, you know, do them on your own time. But yeah, we'll get back into those cooling coils real quick. Show you.
You say you're gonna try to get some people in this Saturday?
Yes, this Saturday. Yep, I'm going to be doing 1 hour sessions. I just got, the dean just emailed me saying that I can get up to 9 people at a time. because nobody's in the building. So, because if I do it on a weekday, I can only get like 3 people at a time.
Gotcha.
I'd rather do, let's get 9. I'm going to be there. My plan is to be at the school from 8 to 6. And, I've got y'all, I've got my other evening class and my 2 afternoon classes. So I should be able to get everybody in at least an hour. I'm going to try and send out I got to figure out how to do it, to share out a Google Drive like sign up sheet. So that way it can stay live and people can just sign up for time slots. And once it's full, it's full. But I got to figure out how to do that basically because I'm not the best with computers. So, but yeah, that way everyone can just sign up for their hour slot and whatever they want to do. And, I'll email you ahead of time to say, what tools or supplies or anything like that you're going to need. Yeah, we'll be, that's the goal. So just the fact that now I've got a plan and we figured out some stuff last week and it's just been good. So I'm hoping we can get that figured out and get some time in the lab and get y'all actually not just, looking at this stuff online, but wire it up, get your meters out, test it out, do it all. Because I'd like to have, eventually the goal typically is to have it where y'all can wire up a thermostat very easily, by the end of this and everything. So I want you to have that confidence, but it's going to be tough. If nothing else, honestly, I know I'm going to be doing some lab work on some Saturdays probably in the next mod as well, just because it's what's going to happen because we have this craziness going in. But let's go ahead. We'll do guided practice. So where are we going to always first thing?
Thermostat.
Thermostat. Isn't that thermostat? What are we going to do there?
Set it to cool.
Mm-hmm. So we're set to cool. What are we going to check next?
The
Fan
indoor
motor.
fan.
Yeah, we're going to check that indoor fan. The indoor fan is off.
Outside compressor.
Yeah, let's check that outdoor unit, see if that guy's on. Fan seems to be running. Compressor's running. So outdoor unit's running, but indoor unit is not. We're gonna head to. Say again.
What was the
The
question?
indoor fan. The transformer.
Yeah, let's go to that transformer. Let's see. We can check that if we want to. Check CR 240 coming in. Check CR 24 coming out. Yep, so transformer looks good.
The capacitor.
The relay.
Capacitor. Let's see how that guy's doing. So how do I test a capacitor first of all? What have I got to do to test a capacitor?
The meter, right?
Yep, you're going to use your meter. What setting am I going to have on a meter? What am I going to look for?
Is it amps?
Nope.
It's not ohms, right?
On y'all's meter, it is on the ohm setting. It's one of the, if you go to resistance and you hit select 3 times, it's going to bring up a different thing that's called microfarads or
Microfarads.
capacitance.
Oh, okay.
Yeah, a capacitor, you measure capacitance. It's you'll see it advertised by different meter manufacturers. Reads true capacitance. It's like, okay, whatever, I don't care. As long as it works, it works. Y'all's meter is excellent. I love the UBIs, they're great. So you check for capacitance, and what you're looking for is what you have to do with the capacitor always is it kind of acts like a battery for our motors. It helps kick on that startup and everything. Because of that, even when I disconnect power from the system, and even when I disconnect my wires from my capacitor, it can still have energy inside of it. So you have to discharge it. You can use a discharging resistor, which is weird because nobody I know actually does that. Typically what you do is you take a pair of well-insulated pliers or an insulated screwdriver, and across the terminals, you just make contact one to the other, and that discharges it instantly. After it's discharged, then you're going to put your meter on and check for microfarads. The trick with it is, I will say, give it a second. Does not read instantly. Microfarads take a minute to read because what happens is your battery in your meter actually sends a signal through the capacitor from one lead to the other to measure capacitance between the two. It takes a little while to calculate. You'll see your meter actually go like beeps across and just little dot, 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 like it's thinking, or someone's sort of like when you're texting somebody and they got that little text bubble is like chatting back at you. That's pretty much what your unit's doing. But we just checked our capacitor. It's reading 10 microfarads, which is what it should be. So that's doing fine. So we've got a good transformer, a good capacitor. All right. What else do we have for that unit?
The relay.
The relay. That's our last thing we've got with that indoor unit. We'll have that relay. So we have it. Oh, come on.
We're looking for 240 coming in and 24 coming out.
240 coming in, 240 coming out, and we should see 24 on the coil. That's what we're going to look for. So we'll start with the 24 on the coil because that's our low voltage. That's easy one to look for. All right, so I'm reading 24 across that coil. So I've got my low voltage. And we're saying high voltage. Let's check our high voltage coming in. Ooh, we got no high voltage coming in. That means I'm probably got no high voltage going out. Definitely. All right. So what would cause my high voltage to not make it to my relay?
No power on the.
I would have thought that would have been the transformer, but we checked the transformer.
Yeah, so the transformer's getting 240. The outdoor unit is getting 240. So everything's getting its high voltage except for this relay and that fan motor. What do you guys think might be a thing that could cause high voltage to stop flowing to one component?
Loose wire?
Could just be a loose wire. Let's check and see. Well, that black wire for our power was loose. So now if I check my voltage across that, ooh, wrong tool. Do not need a leak detector right now. So now if I check my voltage coming in, now I've got 240 because it's actually making contact. Coming in, and I've got my 240 coming out. So the relay's working, just had a loose connection. And again, this is the kind of stuff that gets overlooked because, and I know I do the same thing. It's like, it's no way it can be something that easy, It's got to be something complicated. It's air conditioning. But a lot of times it ends up being just loose connections, poor connections, damaged wires, stuff like that is very, very common to come across.
So how much is that job? How much is that?
The loose wire connection, man, it's tough. I always had it where it was, it would come down to how long it would take me to diagnose it sometimes, but typically if it was just a loose wire, I just had to run a new one or repair one really quickly. Maybe $100 at most kind of thing on top of the dispatch fee. So like $180 is what it ends up being for the day.
Gotcha.
But yeah, it's your company, they'll have their set price and price books hopefully and everything. So you don't have to think about it, but it's it comes down to, you know, if you're planning to run your own business, especially, you have to factor in a lot of things with your price. It's not just, well, how many, you know, what's the dollars per hour that I'm paying the technician? Okay, he's being paid, let's say $20 an hour. So I need to make $20 an hour on his labor, and then I need to make, you know, $80 on the dispatch fee, and then I'll make, you know, just we'll do 50% more on my parts, you know, cost. And that ends up being a lot less money coming in than you need, because you have to charge for more than just what the technician's getting out there paying for. You're paying for the manager, for the call dispatch team, for the online advertisement, and for the rent of the building, the truck to get out there, all that kind of stuff. So it gets tough when you have to factor